In this unit, we're going to talk about scientific notation and specifically why we use scientific notation. We're going to then change numbers to and from scientific notation, I should say backwards and forwards, to scientific and then back to ordinary notation. We're going to use our calculator to do some calculations in a very simplistic way by putting numbers in scientific notation. And then we're going to understand engineering notation. So first of all, scientific notation is a number that is expressed as a product of a number that's greater than or equal to 1 and less than 10 times a power of 10, 10 to some power. So, for example, here's a number that's greater than or equal to 1 and less than 10, 9.24. And here's it's multiplied by a power of 10. And this right here is called shorthand notation. And this times 10 to the 7th behaves like exponents behave. So there's going to be some cool things that we're going to do with this when we multiply and divide. When we multiply, when we have times 10 to a power and several values, we're going to add their exponents. When we divide, we're going to subtract their exponents. Just like we learned that x to the second times x to the fourth is x to the sixth. Again, we add these exponents to simplify this expression. That's one of the reasons we put numbers in these forms. Again, the other reason is to write it in a more simplistic form, because this particular problem, times 10 to the 7th, means times 10 times 10 times 10 times 10 times 10. I'm exaggerating. Well, not really. It's the truth. Let's see. 1, 2, 3, 4, 5, 6. It looks like I need one more. Well, times 10 to the 7th means to take the number 9.24 and multiply it by a 1 with 7 zeros. 5, 6, 7. In other words, multiply it by 10 million. And so essentially it means take that number 9.24 and move this decimal place 7 places to the right. So there's 2 spots, 3, 4, 5, 6, 7. I'll put my decimal place right there and I'll put zeros here. So again, I have 92,400,000 when I move that decimal place 7 places to the right, multiplying by 10 to the 7th. And one of the other things that I always remember is that when this exponent is positive, the number becomes very large. When this exponent is negative, the number becomes very small. It's because 10 to the negative 9 right here is the same thing as dividing by 10 to the 9th, which is a 1 with 9 zeros. Well, you take the number 3 here and you divide it by a 1 with 9 zeros, a billion, you got to move this decimal place 9 places to the left. So it's going to become, I'm going to put 8 zeros in front of the 3. 1, 2, 3, 4, 5, 6, 7, 8. And then the 3, 0, 0, 7. And I have just moved the decimal place that was right here. I have moved it 1, 2, 3, 4, 5, 6. 7, 8, 9 places to the left. So 10 to the negative 9 means make it very small. You have to be very careful saying to yourself that because it's negative I move to the left. It is true when going from scientific notation to ordinary notation. That's what we're doing right now. So 5 times 10 to the negative 4th. The decimal place is right here. So I got to move the decimal place 1 and then 2, 3, 4. So I have to put 3 zeros in front of the 5. 1, 2, 3, and then the 5 because I moved the decimal place from here 4 places to the left. This one, though, times 10 to the third means make the number bigger because you're multiplying by 1,000. 10 to the third is the number 1,000. So you got to take that 5.83 and you got to move the decimal place 3 places to the right. Again, it was right here, so I'll go 1, 2, 3. And I've got this now in ordinary notation. Now to go from ordinary notation back to scientific notation, that's a little bit, it's just backwards is all. So you're taking this very large number right here, and its decimal place is currently right here, and you want to move its decimal place until you have only a single digit. You want to move it right to there so that you only have a single digit to the left, because the number you create, which is going to be called 8.3, has to be greater than 1 and less than 10. So the number 8.3 is less than 10. Now you got to have a times 10 to some power. Here's the dilemma. Some people think that they move this to the left, so it's a negative 7, but it's a positive 7 for an exponent, because this was 83 million. So you have a very big number and you have to have a positive exponent. So to get it back from this form into this form, you have to move this decimal place 7 places to the right in order to give you this. So the number 6 is a very small number. So you got to take this decimal place and move it 1, 2, 3, and you got to stop right between the 4 and the 7, because you want this number to be between, I kind of often say between 1 and 10. So it is. It's between 1 and 10. You moved it 4 places, so you've got to write this as times 10 to the negative 4, because in order to take this number and get it back to this very small one, you have to think of this 10 to the negative 4 as 1 over 10 to the 4th, or you're dividing 4.7 by 10 times 10 times 10 times 10. I think I said that 4 times. It's supposed to be 4 times. So anyway, a very small number in scientific notation has a negative exponent. A very large number, whose decimal place is right here, in scientific notation, it's going to have a positive exponent. The decimal place has got to go right there, because you've got to have a 2.704. You don't have to write anything else after that. Again, positive exponent, I went 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11 spots, and I've put this in scientific notation. Here's my decimal place. I got to move it between the 2 and 1. So I have a 2.1 times 10, and then I went, let's see, 1, 2, 3, 4, 5, 6, 7, 8 spots times 10 to the negative 8, because this is a very small number is how I think through that. Let's see what we've got next. Let's change from ordinary notation to engineering notation. That one's kind of fun, and engineers think like this because the world thinks in the metric system. And so engineering notation allows us to do that. In engineering notation, you need to make the first digit, the first factor, to be between 1 and 1,000, no longer between 1 and 10. So you have to move this decimal place right here. And then again, got to make this between 1 and 1,000, but you have to move in multiples of 3. Multiples. So 3 at a time. So from here, 1, 2, 3, 4, 5, 6. You cannot go again. 7, 8, 9. You cannot go there, because if you do that, moving your decimal place right in front of that 5 would give you a 0.572, and you have to be bigger than 1. So we've got to stop right there at the 572, and so we have to call this 572, and that is because I want it to be between 1 and 1,000, and then I moved 6 places, so 10 to the 6th power volts. Those of you who know the metric system know that 10 to the 6th stands for mega. So you would also be welcome to change this to 572 and replace this 10 to the 6th with a capital M. That's what mega is, volts. So that's one of the other reasons that we do this, because then I can change my prefix for the units of voltage. This 1,352 has a decimal place right there. I have to move my decimal place 3 at a time, and I'm going to have to stop right there. So it'll be 1.352. I moved it 3 places to the left. And so this value is times 10 to the third. 1,352 is 1.352 times 10 to the third. Now, that is milliamps. Milli means 10 to the negative third, so anybody who would like to think in terms of prefixes, I'm sorry, that's supposed to be a positive 3. I'm replacing this one right here. So this is 10 to the third, and milli is 10 to the negative third. So those two would add together to be 0, 10 to the 0 power, or 1. We can also call this number 1.352 amps. And I got rid of that prefix. Wasn't asking you to do that, but you can. See this decimal place? Move it in multiples of 3. 1, 2, 3. 1, 2, 3. Can't stop there because I'd have 0.054. Move it 3 more times again. So when you do that, you have the number 54. Remember, it's a very small number because it was 0.000000054. You moved it 9 places, so times 10 to the negative 9 seconds. Any of you who happen to know the metric prefix for that, I'm going to pause for a minute. 10 to the negative third is milli. 10 to the negative sixth is nano. And then pico is 10 to the negative 9. So you could also call this picoseconds. All right, last one for this video. 1, 2, 3. 1, 2, 3. 1, 2, 3. Got to stop because I have a 40. The number's got to be between 1 and 1,000. It's times 10 to the 9 places, bytes, kilo, mega, giga. So 10 to the 9 is a capital G, gigabytes. So if you wanted to, you could replace that 10 to the 9th with that capital letter G. We'll do some calculations in the next segment and do some story problems.